Okay, hello everybody. I'm Paul. I'm going to talk about a rarely talked aspect of gem5, which is integrating gem5 into another simulator. Okay, so this is entirely optional. You can choose to do it or not to do it. But that's one thing I want to point out. If you ever want to use, this is a good slide for this. The first command would be how you compile gem5 as a library. And then the following ones are how do you compile gem5 component, which is some SST sim object. And then you can use the lat command to run a simulation.
I have a question, Mark.
Yes?
Are you going to talk about what it means to compile gem5 as a library?
Depends on what do you mean by that.
So what's the difference between compiling gem5.opt and binary gem5 and compiling gem5 as a library?
So yeah, usually we use gem5 a standalone simulator. So we compile a whole binary, and then you can run simulators. You can run simulation from that. But when you use gem5 as a library, you have to use a different command to generate the library binary. Does that answer your question? And then
Not really. Maybe I can answer my question. So having gem5 as a library allows you to link into gem5 and have an external thing use components of gem5. One of the ways is using SST. There's at least one other using system C as the driver and using components of gem5. And in fact, I think someone asked at one point, can we do all the configuration from C++? There is an option when you compile gem5 as a library to compile it without Python. And then you have to have a way to do all of the instantiation and everything from C++, which you can do, but it's a bit of a pain in the ass. So.
Hi, Jason. Okay, so I'll try to run this command. Okay, it looks like it's compiling. So back to the talk. So how does that look like when you try to set up a gem5 sim object in another simulator? So assume that the whole thing is the other simulator system, which is the main driver for the simulation. And then you set up the components of the other simulator. And then you set up the gem5 component, which is will set up the whole gem5 Python environment if you choose to use the Python environments interface. And then in that step, it should set up the whole hierarchy of the sim objects, like you specify in the Python configuration script. But how do you interact between the component of the other simulator and the gem5 sim object? So you have to do something in between, right? So oh, yes.
What's an example of why you would use gem5 as a library?
That's a good question. I don't know the use case of System C gem5, but for gem5 SST, the main reason we did that is that we want to do the multiple node simulation. It's not that straightforward to set up a multiple system in gem5. So we chose to integrate that with SST so that we can get the benefit of parallelization in SST itself and the benefit of linking between the gem5 node by using SST components. Does that answer your question? Okay.
Let me give a slightly different answer. Sorry. Paul.
Oh, yeah.
Some people have their simulators that they use that they like, and they have things that they've developed in SST or in System C or something else. Then they want to use a component from Gem5 and not develop it themselves. So we give them these links such that you can use parts of Gem5 if you want to use parts of Gem5 along with whatever simulator you're using. Maybe we should talk about doing this with Synapse.
So not only you have to worry about the connection between the gem5 component and the other simulator component, you also have to worry about the translation between the gem5 event or gem5 packet with the other simulator's language. So to recap that, how do you set up the gem5 simulator as a library in another simulator? So the first step, you should bring up the Python environment if it's not exist. And I believe that you have to manually import the M5 module as well as the gem5 module. And then in another step, somehow you have to read the gem5 Python system configuration file in order to set up the SimObject hierarchy. So remember that in gem5, when you set up the SimObject, after you call m5.instantiate, you cannot further modify the hierarchy of SimObjects. So you have to do something in order to, at the time that gem5 does instantiation of the system, it have a port or a connection to the other simulator already. Okay, so another thing to think about, or I believe that you need to figure out when you set up gem5 as a library in another simulator, is that gem5 itself has an event queue, and if the other simulator is also an event-driven simulator, then essentially you have two event queues, and somehow you need to synchronize them. And so since the other simulator is the driver simulator, so you should use the clock of that simulator. And then there might be some mismatch between how the internal interpretation of gem5 ticks and the other simulator clock tick. So you need to worry about that as well. So essentially, after you set up everything perfectly, this is how the simulation look like. So as I mentioned, the other simulator is the driver. So it will handle the clock, and it will decide when to advance some ticks up. So for every clock tick of this other simulator, the external simulator will advance the events in other components, and then when it reaches gem5 system, then gem5 system should advance that amount of ticks as well. Okay, so this is a case study of gem5 SST integration. So I will give you a brief introduction about SST simulator. So I assume that you more or less familiar with gem5. So I will use analogy here. So SST is a structural simulation toolkit. Itself is a simulator. And the main point or the main feature of this simulator is that, so remember that in this slide, I have this component setup of this auto simulator. In SST case, you can partition the components into several partitions, and then you can run them in parallel. And then I believe that they use MPI for communication between the components. They also have SST element, which have a lot of components like memory system or CPU object or something like that, and SST macro. So SST, what is the simulation of object in that simulator? It's called SST component. As you can see, there are 4 components, and which kind of similar to gem5 object, which you can parameterize or it basically represents a component in your system, like CPU, hardware, the CPU, memory, DRAM, cache, anything. This can even be a whole system. Then SST link. So SST link is how SST components communicate with each other. When you set up a link between 2 components, they can send event back and forth. Basically, it's a bidirectional communication link. Remember that in gem5, we only have one direction. You can set up a request port and response port. So you can only send requests from request port to response port and receive the request back. You cannot send a request from the response port. Good. An SST event. So basically, it's kind of analogous to gem5 event and gem5 packet. So if you're not familiar with gem5 packet, it's usually it is how gem5 send the memory data between 2 sim objects. So it contains data and the destination and the source of the event or the package. So as I mentioned before, this simulator is heavily parallelized. The components are partitioned into multiple components, and then they communicate with each other. So it's for several processes, and then the components cluster or partition will live on each process, and they can communicate with each other via MPI. And the cool thing is that you can do that automatically. They have some library for that, or you can choose to manually divide your components as you want to. So I believe that Mihir did a good job of introducing you how a sim object interact with the memory hierarchy. So this is the figure that I copied from that slide. So basically, I assume that here we have a request port in gem5 and a response port that's supposed to be in the external simulator. Then what happened when you when gem5 send a request to the other simulator? Then the send timing request will be function will be triggered, and then the response port should be able to receive that timing request, or basically it should have the receive timing request function implemented. And in another way around, when the external simulator send the response to gem5, the response port should be able to do or trigger the send timing response function, which in turn trigger the receive timing response from the request port. So far so good, but there's one missing thing. So when you communicate between gem5 and the external simulator, you have to translate the the packet format or an event format of gem5 to the other simulator, and this is where that should happen. So when the response port receives the request, it should do the translation before it's send it to the external simulator. And when it's received a response, it should do the packet translation. So so here what's been going on so far is that we have the request port in gem5, but something in the external simulator must understand about the response port. So for this gem5 and SST case, I found that it's easier to implement to extend the response port to something called outgoing request bridge. So it's a gem5. It's not. It's a gem5 sim object that will be responsible for when you do instantiation. It will be there so that the gem5 internal will not complain about you have a port that's not connected to anything. And then also gem5 provides interface for the response port that the external simulator port is expected to be inherited from that class or interface. So in SST, we make a component, we call it gem5 component, which basically brings up. So what it does is that during the constructor call, we brings up the gem5 Python environment, and then we do the whole instantiation, gem5 instantiation during that call as well. And in that component, you can have multiple ports to communicate between gem5 and the other simulator. So what that component does is that it contains the whole gem5 system, which have simulation object, as well as the port that responsible to be acted as the a responder. And that component is also responsible for the packet translation between gem5 and SST. So basically, you can choose to do the translation either in gem5 or SST. You can do that either way. There's no preference. But in my case, I figured that out that it's easier to modify SST than gem5. So this is like the whole architecture of that. So hey Jason, how do I use the? Oh, okay. So this is the whole gem5 stuff that lives within SST. So everything about the Arithmetic light over there is the gem5 is within gem5, and then we have SST memory system, and which connected to a gem5 component. So in this case, we implemented to outgoing request port or outgoing request bridge, which be connected to the gem5 component by the SST responder using which implement the SST responder interface. So we have two of them. And so let's see what happens when the CPU sends a request to this memory system. So first, it will, from the CPU, assume that it's a data cache request port. It will, from the packet will be sent from CPU to the request port. The request port will be owned by the request bridge. And the request bridge, in turn, send the package, not doing this translation, but in turn it will send the packet to the SST responder, and then its owner, the SST response subcomponent, will do this translation here, and then send the event to the SST component, memory component. So the other way route, you can even send a response from SST memory back to the CPU. It looks something like, so it looks something like this. The SST memory system will send the response back to the SST responder, which will trigger the owner of that responder function, which in turn send the response. Oh, so the translation also happened there, and then before that, and then it will be sent to the request bridge, which will going to be reached by the request port, and then it go back to the CPU. So basically, if you want to integrate gem5 to another simulation system, I recommend that you have a kind of some high-level structure of how the gem5 component will interact with the component of another simulator back and forth, so that basically you need to figure out the data flow between them. So we have example of the integration. You can find the gem5 system configuration in gem5/extension/SST, and the SST system configuration in extension SST example.py, and then gem5 system examples system configuration in gem5 configs example SST RISC-V fs.py. So in that setup, we let SST drive simulation. We have one gem5 component which consists of 4 detail core, and the cache and memory, the whole memory hierarchy would live in SST. So after we implemented that, we figured out that there's a lot of limitation of if you try to. So in the setup, we have CPU system in gem5, and then the rest of the memory hierarchy in SST. The problem is that there's so when a gem5 core need to do something, it will make a new event to in its event queue. So essentially, it will make a new event every as dense as the clock frequency, and it wakes up very frequently. So effectively, you have to synchronize between the cores very frequently. So even though we have SST is very highly parallelized, so this should not be the use case for this. And another limitation is that we failed to get the block device to work within SST for communication with gem5. So, but this this setup, this gem5 SST integration is useful for multiple nodes simulation. You can set up each gem5 component as a whole system, and then you can have a link between those gem5 components, and then you can set up each gem5 component to live on a different process, and then they can move forward until, I mean, the point is that at the node granularity, they synchronize not that frequently. So each node can advance as far as they want until the next synchronized event is. So we don't have an example for this yet, but I believe it's very straightforward to do that. You can set up, as mentioned, you can set up a gem5 component to have a whole system, and then have a PIO device that can communicate with at some specific address, and then send the request to that address, and then communicate with another node via that specific physical address. So another thing I want to mention is that so far I mentioned that you need to bring up the Python environment, but in SST case, it's also used the Python environment for the interface between the front end and the back end. So by the time we reach the gem5 component instantiation, the Python environment has been brought up by SSE. So you need some. In that case, you cannot use gem5's instantiation call, but you have to modify it so that it will work in some environment that already have been set up. And then you need to manually import the M5 and gem5 libraries. And one thing I found very useful for integration is that, so remember that when you set up gem5 and you set up the auto simulator, somehow you need to link between one component in the external simulator and a gem5 sim object. So how do you find the gem5 sim object? You can use the M5 library, which have a function called find object, which if you give it a name, it will find the object for you. So you can use that function to provide a link between a gem5 sim object and another simulator component. So here's so in my slide, there's documentation for the whole setup, how you set up the interface for gem5 to communicate with the other simulator, as well as an example of how you set up gem5 in another simulator. And then we provide resource which have the bootloader, the kernel, and then the custom workload that built in one binary. And you can find that in that link. So that's the end of my session. Let's see if we can run. So let me quickly demonstrate how do you run it in CodeSpace. Okay, it will take a while to download the Docker image for the gem5 SST integration.
Any questions from Mohammed while this is going? Questions about SST integration or other kinds of simulator integrations?
Yep.
So I've always explained this, but is it SST or gem5 driving the simulation? Who's carrying forward the simulation? Who's causing that? Let's say who's triggering the ticking of the statue?
I've got a question again.
Who is actually initiating the triggering, like events, right?
Yeah, so with
So the question is, the question is that how the events are triggered.
who's choosing the next best?
So remember that in this for loop, this simulation for loop, when another component of the external simulator advances a few ticks, then if it's so in this gem5 SST case, a component a component in SST can send a response back to gem5. If it happened at that time, then we will receive the gem5 event queue will have a new event added to it, so that when you call gem5 system events a few ticks, then at some later time that event will be received, and basically, like if the other component sends a response back to gem5, when gem5 execute that event, it will get the response to the CPU. And the other way around, when gem5 events a few ticks and it want to make a request to SST, then an event will be added to the SST event queue.
In terms of the events being taken out of those queues, so you're doing a queue on the SSD side and a queue on the gem5 side?
Yeah, basically we inject event into the event queue on both.
Okay, and then is it just a point of synchronization of following events?
I believe.
How's that pulling out?
I think, and correct me if I'm wrong, the right way to think about it is that the SST event queue is driving things, and one of the events in the SST event queue is to tell gem5 to check.
Well, okay, so gem5 is the point, is like the point for the SST simulation, right?
Yes.
Right, okay.
Correct.
Yep.
Okay.
Okay, yeah. Thanks.
It doesn't have to be that way. It could be the other way around.
Yeah.
Since SST was parallel, that was what we were doing.
Okay, so far I compile the component, and then I can run the simulation. So if you set things up correctly, it will run. But in this case, there's some update in the gem5 main line that have been made that I haven't fixed that here yet. So it's rather simple fix. I think you can figure that out. So the error is that the platform doesn't have the PCI host. Basically, it's a dangling port. So how to fix that is that you go back to gem5 configuration. System. Go to where the platform is created. It should have a port to the PCI host. So it's a PIO device. So the way that you get a port from a PIO device, that you use the PIO parameters and connect that to the system members. And with that fix, it will start a simulation. Okay. So that's the end of my session.
Any other final questions about SST? So with this, while it's now booting Linux under RISC-V, we're using with SST driving the gem down. So if you're interested in this later, there's a bunch of code that's around this kind of Any final questions? Okay, cool. I think for the sake of time, we're going to jump right into the next topics. Juan has a couple of little things he's going to talk about. Is that right?
Oh yeah.
And if I just say something and talk to him, Sure.
Some people have questions about how you check out of your accommodation earlier. Apologies, I wasn't clear. It certainly wasn't. I wasn't for anything, but I emailed the place this morning. So you have to go to the Segunda Services Center to check out, and you have to do that within their hours, which is it's any time from 7 a.m. and 11 p.m. Otherwise, you have to pay a fee. So please don't check out after 11 p.m. You can check out at any time in those hours. Is there anything else here that I think is important? Oh yes, and you have to check out by noon tomorrow. So can't say later than that. So noon tomorrow, check out at the Segunda Services Center. Has anyone got any questions about that? Is that all pretty clear? Yep.
So there's nothing you have to bring to check out?
I think it's a bring your little key card thing, but you do have to go there and check it out. Okay. Happy to clear that out for anyone.
So now we quickly go through the extra topics that you all would like to talk about. Okay, so there's somebody asked about the bitwise arithmetics in gem5. So we have some API for that, which is, I think most of them are tested. So it fits your use case, and you probably should use that in gem5. So The functions that I'm going to present are going to be for integer arithmetic. So you should expect the input and the output to be integers. So let me quickly go to the code. So you can find those function in gem5 source base, I believe. Should be in math, yes. Okay, so we annotated at the API for gem5. So it have function like floor log2, which compute the floor of log2 of an integers. And seal log2, basically the same function, but you use the seal function instead of the floor function. Power of 2, you check if whether a number is a power of 2. And then dip seal, which is you do division and then draw it up. So this is the interesting part. So we have implementation of multiplication of signed and unsigned variable, and we have output at the high and low, and the input as val A and val B. What it does that it does multiply A and B. So remember that when you do, for example, 64-bit multiplication between two 64-bit numbers, the result would be 100. I mean, at most it would be 128 bits. So in x86, when you do that multiplication, it will reduce. It would write back to two registers. So this is what exactly what it does. It's a helper function to help you to do that. It will get the least significant bits in the low variable and the most significant bits in the high variable. So we have similar things, but if you look deeper into the API, we manually do that at some point. The reason is that so usually we use 128 bits variable to store the result, but this type only exists in GCC. It is not supported or officially supported in Golang. So if we detect that it's not supported, then we go back to manually multiplying two 64-bit integers. Any question about this? So basically, essentially, it's a helper function for multiplication in x86. And then there's some useful function for memory alignment calculation. So you can choose, you can get an address and then draw it up or draw it down to up to the alignment of your memory address. Yeah, it's essentially what it does. So so the input to the draw up and draw down function is, the first parameter is the address, and the second parameter is the power to like the granularity that you want to access the memory. Okay, any question about this?
So just to kind of a slightly higher level, if you ever need to do bit manipulation or anything, there's already functions to do it. You should never write anything like doing any kind of bit manipulation in Gem5. Use these well-tested functions. The number of bugs we've found because someone tried to re-implement bit implementation and did it wrong is, I don't know, a handful. But still, it's bugs that shouldn't happen because we already have all this.
Okay, so the next topic, what I said I put on the slide so you can look at it later. So the next topic I will talk about is Affress Interleaving, which I learned yesterday. The idea of Affress Interleaving is that, so remember that when you send a memory request, so the DRAM or your memory device will take that request. And there's some parallelism in a memory access. You can send multiple memory requests, and if you send it to the right set of addresses, then you can access them at the same time. So it will increase the throughput. For example, if you can access the banks or the channel or multiple memory at the same time. So if your memory controller or DRAM controller figure out how which bank and channel that it can send to, then it can send the request to basically it will pick which bank or which channel the request will be sent to. So the essentially how to pick the bank or channel. So what this is Affress Interleaving about. You use part of the physical address. You can use part of that, and then do some arithmetic to figure out which bank or which channel that you want the memory request or response to be routed to. So for selector, I mean, the arithmetics that you choose which bank or channel that you want to access. You can do a lot of things with, you can basically do anything with the selector, but it's what I'm trying to conceive is that it's a one-to-one mapping between the selector and the bank and channel. So how do you use that in gem5? So in gem5 we have address range constructors, which located in source base address range. And we have, I believe, 2 implementation of Affress Interleaving. So if you look at the constructor of address range, then one of them would be, if we start with construct address range, what it does is that it set up an address range, like from one address to another address, and the addresses will be split up by the selector, or how do you identify the selector. So in this constructor, it takes the start of an address, the end of an address, the masks, and the interleaving match. So what is the mask? So the mask is the setup bit that will be used for selector. And so you can have an array of setup bits. So I think it's better explained by example. So if you set the mask to be 8, 11, 13, then the bit 0 of the selector would be the XOR of the bit 8 of the address, the bit 11 of the address, and the bit 13 of the address. And if you set the mask to be, so this is the first mask. This is the second mask. So for the second mark, with corresponding to the second bit of the selector, it will be the XOR between the 15 bit, the 17 bit and the 19 bits of the address. And then by using the mask, you construct a selector. And then the interleaving match would be the matching value for the selector. So this is because when you construct an address range, so for one selector value, you set up one's corresponding address range. So any question about this? So there another way of constructing the interleaving address. So this is a less general case of deformer. So in this case, instead of using a discrete set of bits, here you use contiguous part of the address and then XOR them together. And then from that, you get the selector bit. So if you want an example of this, you can take a look at how the multi-channel memory is implemented in source. Python, gem5, component, memory, multi-channel. Which implement channel memory, which is so by default, the multi-channel memories will be set up using the second type of interleaving constructor of the address range. And you can find that in source, Python, gem5, components, memory.py. And this is how it's set up. Good. How about this? Okay. So we back to Christoph, which
It's gonna take more than 15 minutes, don't you think?
I can run examples or
Let's do it after
Yes.
lunch.
might be a good idea. Okay.
We're doing online reordering here.
Yeah. So take advantage of all the time we have before lunch. So one thing I've been asked, I think at least 2 times in this is, when we're using the Star library, I told you how to simulate to tick, which that tick's kind of an annoying arbitrary thing inside Gem5. It doesn't really mean very much. So people are like, what about simulate to a particular instruction inside a simulation, like instruction 100 or 1,000 or 1,000,000 or whatever else. So I'm going to briefly show you how to do that. I'm going to have a giant disclaimer here that this is not really properly supported by the standard library. And that's on me. Next version, we're going to have it in. But I'll show you how to do it for your own work when you want to do this sort of thing. So where's code spaces? Is it even open? Oh, there it is. So yeah, I was just there, background again. Okay, cool. So this is the way I did it on my machine. If you go to our materials, oh, I'm going to close all this. close. You go to the materials and then the using gem5 and go to the standard library stuff we did on Monday and then complete. And then let's just take the hello world complete example because that's a very basic simulation. Okay. I'm just going to use my own laptop for reference because I had this in my own machine. So essentially how the to max instruction works is it's you can set it at the level of the CPU core inside gem5. So that means we need to get the core available inside the script. And the way you do this in standard library is you do processor and then get cores. So that just returns a list of all the cores inside the processor. I'm going to keep this example is very straightforward. There's only one core, so we're going to get the one at index 0. This, just take my word for it, .core, that's literally returning the core sim object, right? And then the core sim object has a parameter called max underscore inst for instructions, and then we're going to do any underscore thread. And from this, you set the max instruction you want to go to for that core on any thread. So let's, I'm going to do very low. I'm going to do 100 because this is just our hello world example. So I want it to exit relatively quickly. And I think that's all you need to do. So if you'd save that, oops, Control S. If you go to your terminal, and then just execute that as we've done many times before. So gem5, x86, materials, using gem5, 02 stdlib, complete, and hello world complete is the one we modified for this. And you run it. Now you do get an error, but it's quote, a good error, because it's saying, hey, we reached the maximum instruction count. And the reason the error is being put out is the standard library doesn't know how to process that event right now, because I haven't implemented that yet. But your simulation has exited when it reached that instruction count. I think it would require a slight modification of the standard library, but like a very slight one. I might even push the patch this afternoon just so it's on develop. And if you're not using the standard library, you just need to find your CPU core and set that parameter inside the core, and it'll exit that simulation. There's a couple other ones here that I'll briefly go over. Like I said, max instructions all threads, which will meet. I said any threads, that's one I did. So it's when any of that threads on that core reach that count, it'll exit. There's also all threads you can do here. So you've got multiple threads in that core. All the threads in that core had to have reached that instruction count before exiting. So those are your kind of two options there. But in this example, they're the same thing because we're running one thread anyway. I'm not an... Does anyone have any questions? Because this is a very ad hoc explanation of. Very straightforward. It's just a parameter on the CPU sim object you set, and your simulation will exit at that count.
If anybody wants a good way to contribute, it would be nice if the processor had an interface to set this. So you can just
Yes.
processor dot exit after ticks some number, which should be like 10 lines of code, right?
Or even, I'm not sure which, I have no idea what's the best way to do it. I'd also think maybe the simulator could have a parameter that was like exit at instruction. I don't really know where you want. I think I put it in the simulator module. Yeah, but if anyone wants to do some Gem5 development, I just never got around to putting this in. Yes?
I think SU.py and full system.py was not.
I can't believe you've brought up se.py and fs.py in my presence. Those scripts are the devil's work. They should not be used because there's a reason they're in the example directory. They are just examples of full system and SE scripts that kind of got out of hand at some point and people use them to run experiments with. Yes, I'm sure they have parameters that allow you to set to max instructions, and behind the scenes they're just setting this. The truth is those scripts just aren't very well supported or maintained. They're constantly breaking. They're just giant Python scripts that, yes, I would love, one day they will be removed, okay? Because I'm sick of mailing lists where someone says, I ran this se.py script and it's like 1,000 characters long, and their question is, it doesn't work. Yeah.
I'm very impressed that out of 30 hours of class time, it took 27 hours before somebody asked about SE and FS.py.
Yeah.
You can tell we're very mum about that.
Yeah. It's a
good question. It's what most people think the interface to gem5 is. But as you've seen, the interface to gem5 is Python. So write Python code instead of trying to figure out whether it's a like that. But it's really, it's not that it's wrong. It's that there's lots and lots of bugs in this Python. There's a number of options that sd.py tells you is an option that either does nothing or does something different than it says it does. And so you have to be really, really, really careful. And essentially you have to read all the code and figure out how it works like this to really trust the simulations that you're running.
Okay. I'm not going to take all the time if I don't need it, but we've got 5 minutes. Does anyone have any questions? It's not really worth moving on to another topic. We could just go a little bit earlier for lunch.
Okay, cool.
Okay, cool.
Let's do lunch.